Hello, everyone. Welcome to my session about the modern data architectures. This is an ice-breaking session where we'll be having more session coming in the series. I'll be creating a playlist so that I'll be adding a few more videos about the cloud data architectures focused on Azure, AWS, GCP, and also I will be uh, providing few architectures about how the real-time streaming happens on various different organizations. What are the use cases aligned to it, and how are the tools can be selected for different use cases, because those are the most important thing when it comes to any data infrastructure architecture. Because there are many people who are not aware, the data engineers who are currently running the different type of queries, different type of optimizations. They have to understand the whole data architecture. Mostly during the interviews, when we ask about certain data architecture questions or scenarios or the reason for certain tools, that they are stuck. So my aim is to bridge the gap. Let's talk about on-premises based data generic architecture, because first of all we need to understand about the generic architecture. Coming to the data architecture is like a glacier where you would see only the edge of it, whereas there are a lot of things behind it where we have to understand the reason for the utilization of the tools in a proper way. And also sometimes we have to properly set up a pipeline where every organizations are having multiple streaming pipelines, batch pipelines, and also there are a lot more activities to be clubbed together. The data has to be stored at a proper places based upon the utilization, and also the ETA for every queries reports, or everything has to be aligned on a data architecture. So let's get into the generic on-premise based architecture. Okay, so there are a lot of components here. So let's take this uh, layer-wise approach. First of all, every organization, take it a bank, a healthcare, or a retail, or any industry, let's say they may have their own data architecture for every subdomains of the business, or sometimes the certain companies wish to create their own application. They will have a separate data architecture based upon the applications, use cases, and also the business scenarios. So now we are going to see a generic architecture where every data architecture will have an upstream. Every data infrastructure will get data from various different upstreams. Here, the upstream could be files. So sometimes we get data in CSV files, which would be through FTP servers, through SMTP protocols from different systems, or some. Even I've seen few companies, they get file from the third party applications which write the data in a specific file format. In the olden days, we were using mainframe relevant files with the copybook attached to it. So there are a lot of upstreams which still based on file systems. Many APIs are also writing the data, posting the data in a file. So there are multiple file formats which are currently being used as an upstream. Normally, the upstream gives the raw data where there would be some application or a software which sits between that, and they convert it to a specific readable format or a single unified format. There are some organizations which wants to have everything in a specific single readable format of CSV or a different format. So that those tools work on the file store side. We also have upstream databases. Let's say banks would be having FlexCube or T24. They would have a separate format of data. Healthcare system will have their upstream system, which feeds the data to a database, which could be an operational database, or sometimes even Mongo comes in a place where the retails will have their or transaction databases or staging databases, which would act as an upstream. And few organizations will have IoT devices, let's say the industries, the smart cities, and also the companies focus on certain electronic industries which are actually more aggressive on automations. They are actually having a lot of IoT devices implemented on the equipments, which gives a lot of data about, let's say, certain company wants to have a carbon control or a decarbonization. They capture the methane emission. They capture the carbon utilization or whatever based upon a specific IoTs. And also some companies use IoTs for capturing the wear and tear so that they could predict the downtime of a system. Likewise, there are a lot of innovations are happening. So IoT devices can feed data to us. The device logs, let's say device logs in the sense, let's say there is a company which is having multiple devices on the data center, or a telecommunication company which is having numerous towers which has to be monitored. Likewise, there are a lot of banks which are having multiple ATMs, or there are a lot of business cases. So these devices definitely gives you certain logs. Consider a data center or a cell tower. There are thousands of cell tower. We can collect those logs and have an algorithm built about to it, and so we can predict the downtime. Consider a cell tower with specific type of similar error messages on a particular component would fail in 2-3 days based upon the previous failures. Likewise, in a data center, a system which is giving such kind of error on the hard disk could fail to immediately, and that has to be maintained in a proper way, we know the resolution also based upon the previous tickets. We can easily find it. So this gives the company it's a prediction, so the company can easily prevent the disasters. Okay, and then the web application, there would be certain web applications feeds the data to the data. There are numerous web applications. Every organization would be having, they would be having a different softwares or a different overall portal for getting certain data. So let's say bank or healthcare, everybody have numerous portals through which their relationship managers or the sales team, they work on a specific module. So those applications also feed data to us. These data can be taken on a two different way. One is real time. That is one of the most exciting thing. I will definitely share a lot of video about the real time ingestion streaming, how it works, what are the core components which we have to look when in the streaming, the transaction per second. What are the let's say we have so much amount of data coming. What are the good practices we have to implement? Everything we'll discuss in the future videos. Now, yes, the data ingestion layer should have a proper component for the real time, mostly Kafka. Kafka acts as a message queue. We can have producer consumers on the Kafka for the upstream and downstream purpose. So, and also Kafka has retentions, so we can define the retentions based upon the business usage. If something fails, Kafka gets the data from where it left. So we have a lot of very good features in the Kafka, which I would be definitely sharing a video series of Kafka in future, so that you can learn Kafka from those series. The next is batch ingestion. This is one of the most important thing, where every organizations would be having tools like Informatica Talent for the batch ingestions. So they have they take the D-1 data, they minus the previous day's record, or sometimes the batch happens within an hour. Every 1 hour the batch happens, or 15 minutes. So there are a lot of batches which are defined. So the batch the ETL tool plays vital role on the batch ingestion. And nowadays the organizations are also using NiFi for certain ingestions. There is a lot of conversations, or I would say the blogs are about the NiFi and Kafka. It has different purpose, which where the NiFi mostly for orchestration and also some level of ingestions. Kafka is a message queue system. NiFi is a flow management system. So there are a lot of differences among these tools, and the use cases also differs. So next, once the data are properly aligned on the ingestion layer, the data which are required for the immediate business need goes through the real-time ingestion, and also the data which are required on the micro batches would also can go through the real-time platforms. Then we have ETL, or we can write even a framework on OWN to move the data on a batch mode. So most of the companies, standard organizations uses ETL tool for doing it, and also NiFi, where we can create certain flows of events which can be captured from one system to the other system. The data which are more towards the streaming which needs an immediate results, which need an immediate processing, which are in need of real-time alerting, reporting, those kind of data can be taken to Kafka. Kafka is having a very good streaming capabilities, which means right now we have KSQL, which can stream in a very better way. That is massively being utilized by various different organizations. There are organizations who are using a KDB. Even Kafka has a KSQL which can be queried, where some organizations are using KDB in various different way, which I'll be explaining you in other set of videos. A separate KDB video, which I will be releasing, so that the KSQL and how Kafka stores the data, what kind of time series activities we can do on Kafka, definitely we'll discuss. And the most popular one is Spark streaming. This like it's a micro batch based streaming, where the processing on the data based on the micro batch can be implemented, where we can get the data in we can get the results in microseconds to seconds. So the next is about the Flink, which is an event streaming platform. Few organizations are also using Flink for the streaming, so that they could get the low latency results and also a proper processing. These can be picked based upon the use cases. Not every time we need Flink, which is a kind of a costly on implementation, and also the use case is the most important thing. The next is Spark streaming is widely used, as I mentioned. Kafka is also widely used. So we have to pick which streaming platform we need for our use cases, and also how much data are actually involved on the streaming. That is one more important thing, because I've seen few organizations which are actually getting very less amount of data. In that sense, you have to properly size your Kafka. Sometimes we don't even need Kafka. The ETL tool can solve the problem. So that is one of the most important thing. Not every boxes in the or not every tools in the architecture are required for every organization. Those can be picked based upon the usage and also the unified. Let's say some organization look for a unified architecture, where they know that, okay, this infrastructure would be utilized by 15 business units, so I need to have a drastic, powerful engine. And also I would be having 15 use cases on time series. I would be having 25 use cases, which has a drastic amount of data processing. So in that sense, we have to use this infrastructure in a proper way. We have to size it before we implement it. If the existing sizing is overloaded, we have to add the nodes, or we have to add more capacity to the infrastructure. That would actually give us a much better way on implementation, because I've seen few organizations have sized their infrastructure, either Kafka or Spark, in a way that it can run a specific X amount of workload. When they add 2x, 3x of workload, definitely this infrastructure would actually suffer, which would help you or which would actually give a problem when you have a pipelines which should attain a specific ETA. That would not happen. So that has a drawback. So you have to properly size it. Whenever you implement a new use case on the existing infrastructure, you have to check the utilization of the infrastructure, and also you need to properly assess it and then plan for the resources if needed. So that is one of the most important thing, because I could say that streaming can actually be a delay if you are not properly sizing it. So that is one of the most important thing on any distributed data storage or a time series data storage. Anywhere you have to do a proper sizing, because that is one of the most important thing for any data architect to deploy a new use case.
பிளான் பண்ணி பண்ணணும். Okay.
Then coming below to the streaming layer, we also have the staging data store. The legacy architecture follows the staging layer, where the data comes from the raw system and it gets stored in the staging layer. This is one of the vital component, where we also do first level of data quality checks on the staging layer. The data which also would be validated, and also it can act as a temporary store for a period of time. So once the data are received, once the data are being processed by the message queue, the data would be taken to the data processing. So you would be having a question why we have Spark streaming here. Sometimes I need an immediate result which can be processed directly through the Spark stream. Here the Spark for the batch data processing. The data processing box, and there is a Spark inside, is for the data processing. Most of the data engineers, we know that we work here. So we write the Spark programs, could be Spark SQL or Scala Python programs where we do aggressive computation logics we write here, and we would be having numerous amount of data taken from the Hive table or or from various different data sources, which could actually be processed here, and then the result will be written here. See, this data lake, sometimes we have data taken directly from the streaming or upstream feed to the data lake, and then from here we do the data processing. So this arrow actually should be a double-sided arrow, where the data processing sometimes, most of the times, or it depends upon the use cases again. We take from the staging, or we store the data on the Hive or HDFS. Then we take the data or the previous day data and do the process. So that varies. Okay, not this architecture is not completely accurate. Where some flows we can do it on a reverse way also. Likewise, how we store the data from the Hive can be processed by Spark and the ETL tool. That also happens. That's common. So the data processing happens through Spark, or some organizations are using ETL tools like DataStage, Informatica, Talent for the data processing. And interestingly, there are few organizations who are using Spark through Informatica and Talent, where the Spark jobs are scheduled directly on the Talent big data or Informatica big data licenses, whatever they have. So instead of writing Spark programs, they have the ETL tools which are having the connectors and the stages, which actually creates the Spark job and deploy it on the infrastructure. I deploy it on the Hadoop system. So that is one important thing. The data from the streaming can be is more vital. You could see the the diagram, the lines here. The data from the streaming can be taken to the hot data store for certain consumptions, which could be, maybe I have streaming where I have a pipeline which takes the alert, and also I have a consolidations which happens through the hot data store. So for the alerting system, I send data directly to the consumption layer. From there, the alerting system works. That's a different story. But sometimes I need to have a consolidation. I need to have certain operational tasks which have to be derived from the real-time data. So I store the data on the hot data store, which could have a NoSQL, a time series, and sometimes the operational database also works. So the hot data store is mostly for serving the data for a particular period of time, and the latency should be very good. And also the query retrieval time and the query cost will be very less. So that is the reason why we use a hot data store here. And cold data store for the longer period of storage. It could be a data lake, can be HDFS or Hive data lake, or various different data lake host concepts can be implemented in case of cloud. So that is for the retaining the data for a longer period. The queries which runs on the cold data store would take a long time, because it can go back to 30 days or 60 days based upon the business cases. Those, and also some jobs I don't need to have a ET of 2 minutes. It can run even for 5 minutes, so that I can put or schedule all those jobs on the Spark, on the hot data store. So on the cold data store, sorry. So that is one of the most important purpose of the cold data store. There are some companies after this cold, where they also have archival policies. Let's say data over 180 days will be archived to a different format, or on the same hot data lake. Those are various different areas on the data architecture. Once the data are ready for the consumption, yes, we can. There are some architectures which stores the data from here to the consumption layer for a shorter period of time, or we can directly query. That's okay. We can create a views about to it that can be queried directly by the reporting tool like Power BI. Power BI has a direct query in the Power BI cloud, and also you have this. You can query and create a one from the view. You can consume the data. We also have certain custom APIs we can build for specific consumers, or I would say specific uh, downstream system which wants to take through API, and graph can be built about to certain operational databases, or we can have a specific data stores which supports graph. That is also a consumption pattern. Once the consumption layer is ready, the data can be accessed and the reports can be built. There are a lot of dashboards which has multiple report that can be built. We can also have alerting system. Let's say if the threshold is going above, let's say for a business, I want to send a notification to a telecommunication user when they are breaching the or when they are crossing the consumption time or internet consumption. Likewise, we can send alerting. All those things are real time because people have to notify. Bank systems have a lot of real time notifications. Retailers have a lot of real time notifications on the offers, purchases, orders. Everything goes through this real time alerting system. And every organizations will have multiple different applications. Let's say they need to have a proper banking system which has 1,000 modules which ask data for a credit card, loans, the transactions, a lot of other things. Likewise, retails, you have multiple uh, modules on a single website on a portal where you would get offers, you would get the there will be a lot of algorithms which runs and give you a proper results based upon your purchase pattern. All these are applications. So an organization will have numerous applications which are aligned to a single portal. That is a different story. But internally, everything works as a separate application. And also, we have nowadays a lot of machine learning, AI, and data science models which are aggressively consuming data from the data infrastructure. Okay, so this is a kind of modern data infrastructure which we are using since 2021. The same template I use and create different add different tools for different RFPs and proposals. But the most important thing for any organization with such data architecture is cataloging, so that you would see where the data travels from here to here, how the data are getting transformed. Cataloging and lineage are the most important thing. So on a complex data architecture, once we implement this, we get lost. So we have to properly track the lineage and see how the data are getting consumed. Governance is one of the most important things. Who has to take the data on what permission? What are the policies we have to set? What level of restrictions we can put on organization on the consumption level or utilization level? That is one of the most important thing. MDM, master data management, is another very big subject where we will definitely discuss in upcoming sessions. Data quality, yes. End of the day, your consumption or whatever we give to the customer as an alert or the AI, everything needs a proper data quality, end-to-end data quality. Your quality has to be checked on multiple levels. So the data lake, which are the production, which needs to be properly QC checked. Your data on the hot store should be QC checked. So everything which are ready for the consumption has to be properly quality checked, done, or it should be accurate data. So that gives any organization proper business benefit, because we send some improper results to the customer is actually a problem to the business, because the trust, the data gives more trust to any organization. So that's the reason why data quality is one of the most important and vital thing for any organization. So this is a short session about my data architecture. So this architecture can be utilized for on-premises. So you can please refer this video for any of your data architecture. And if you have any questions or anything, you can reach out to me on LinkedIn. I can give you explanation. I can give you mentorship. So thanks for watching. Let's see more videos in future.